Hello, we are Steve Steel Erections. I'm John Morosi. I'm the project manager. The members of my team are Bryson Killian. He's the field engineer. He'll be getting into schedule and site logistics. And then we have Christian Foster. He is our foreman. He'll be getting into the cost estimate. We are here to present to you the Northern Arizona University Center for Aquatics and Tennis. We believe we are the most qualified for this project due to our low EMR and our past projects. One of those projects being the University of Arizona Recreation Center. Now, Bryson will be getting into the site logistics and the schedule.
Hello, my name is Bryson Killian and I'm the project manager for this project. So I'll be covering the site logistics, phases, crane selection, and the schedule. So moving into site logistics, we at Steve Steel Erectors developed a plan that allows for easy delivery access for trucking and maintains an open job space to provide safety for construction workers. For the erection of the Northern Arizona University Aquatic Center, the structural components utilized in the building will be shipped from Chef Steel just 20 minutes away, traveling west on I-40. The route the trucks will be following consists of getting off the I-40 onto West Route 66, then turning left onto Milton Road. From Milton Road, the trucks will turn right onto Butler Avenue and then make another right turn onto San Francisco Street, which will lead to the job location. Once they are at the job location, they will make one more right turn and enter the project site. Something we considered when deciding the truck route was a path of travel that uses the least amount of left turns to be as easy as possible on the drivers. With the route we chose, the trucks will only be making 2 left turns as opposed to other options we came up with, which had several left turns. We also wanted to keep things as simple as possible once the trucks entered the site. With this in consideration, we created a loading and unloading zone that runs parallel to the steel erection so that the crane can pick directly from the truck. This increases production rate by eliminating the factor of needing a material laydown zone, which also decreases total erection, which then correlates directly to decreasing project cost. However, if needed, we factored in a material laydown area labeled in the logistics plan. This would just be for purposes such as if a worker found a mistake in one of the structural components that would need to be repaired before being erected. We have 2 areas labeled in pink on the logistics plan where we will have a laborer temporarily direct traffic if needed for trucks to get in and out of the project site with ease. For the safety of everyone on the job location, in case of an emergency, we have a large emergency exit at the northmost end of the site, right next to the employee parking lot. Moving into phasing. For the scope of work on the Northern Arizona Aquatic Center, we'll be erecting all of the structural steel members consisting of all of the columns, trusses, joists, and steel decking. We at Steve Steel Erectors split the project into 4 total phases as shown. The erection will begin from the east side of the structure and be erected moving west for each phase. For the first phase, we'll be erecting all the structural pieces, being columns, trusses, joists, and deck, represented by the green highlighted section. In phase 2, we'll be erecting the columns, trusses, joists, and deck, represented by the blue section. The third phase will then consist of erecting the structural steel elements represented by the orange highlighted section. For the last phase of the building, we'll be finishing the entire erection by placing the last of the columns, trusses, joists, and remaining steel deck segments represented in the purple highlighted section. So, for the crane. For this project, Steve Steel Erectors has decided to go with the Manitowoc 10,000 crawler crane. This crane worked best with our idea of breaking the building erection sequence into 4 different phases. Based on the project plans and specifications, we determined the building height of 66 feet 6 inches. With this information, we knew the length of the boom needed to be able to lift each member at the required height. We knew our maximum pick distance was going to be 90 feet. So with all this information figured out, we were able to use the Manitowoc crane chart and figure out which crane's boom length was specified to carry the weight we needed at the correct swing radius. From that, we determined our crane boom length to be 150 feet. Once we determined the boom length, we knew the crane needed to be capable of lifting at least 37,236 pounds based on the largest truss. With the largest truss weight being nearly 38,000 pounds, we selected a radius of 40 feet, which will allow us to pick up 41,200 pounds. The smallest column is roughly 10,000 pounds, so we chose to use a 95-foot radius, which allows us to lift 12,300 pounds. This crane will be perfect for the steel erection because of its fast mobility, and the faster the crane can get set up in each pick location, the speedier the entire erection process will become. Moving into the schedule. For the entire structural steel erection of the Northern Arizona University Aquatic Center, our professionals at Steve Steel Erectors calculated the duration of the project to be 134 days. The project is expected to begin on May 13th and be completed 6 months after on November 14th. The longest scopes of work for the project duration is pre-construction at 93 days and erection at 46 days. For each phase of construction, we coordinated the schedule in a way that allows us to start each phase of erection while the shop drawings on the following phase are waiting to be approved. This allows for the critical path of our schedule to be shorter so we aren't wasting time while waiting on approvals, which ultimately helps to reduce overall project cost. We have accounted for all non-working holidays that occurred during the months of construction and also have considered extra time for coordination with other trades that will be on the project site. The professionals here at STEEF are confident in the project schedule we have created and know we can carry out the project thoroughly and on time, all while maintaining a feasible budget based on our past projects and experience. Thank you.
The estimate for the Center for Aquatics and Tennis consists of all structural steel members. This table shows the quantities calculated for the members of the project. Our cost estimate is shown on this table. We believe that we can bring the cheapest cost for this project. The W-shapes, tube shapes, trusses, and roof deck make up the majority of the cost for this project. Our total cost is $2,850,000 with our bid bond of $285,000.
And that wraps up our presentation. We would like to thank you for listening to us today. We look forward to working on this project, and we believe we are the best steel subcontractor for the job. Thank you.